respected HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. R.K. Himanshu, seminar coordinator D.P. Himanshu, faculty member examiner, and my friend. I am Himanshu. Currently I am pursuing Bachelor's of Technology from University Department, Rajasthan Technology University, Kota. Today I am here to present my presentation on topic vibration analysis in carbon nanotubes. So move on to the first slide. First of all, I will give an introduction about what is carbon nanotubes. So carbon nanotubes are one-dimensional nanostructures composed of carbon atoms arranged in a cylindrical shape. They consist of unique properties that make them highly attractive for various applications in material science, electronics, energy storage, and nanotechnology. So now we discuss about the properties of carbon nanotubes. So with the first property is this structure of carbon nanotubes. So carbon nanotubes are composed from graphene sheets rolled into seamless cylinders. These atoms are packed in a hexagonal pattern, and they have two types of single-wall carbon nanotubes and multi-wall carbon nanotubes. So the carbon nanotubes, which consist a single layer of carbon graphenes, are called single-layer carbon nanotubes, and the tube which consist more than one layer are called multi-wall carbon nanotubes. Second properties are exceptional mechanical properties. Tubes consist of extraordinary mechanical properties like high tensile strength, stiffness, and resilience, which make them one of the strongest materials known. So now we move towards the third property, which is electrical conductivity. Carbon nanotubes consist excellent electrical conductivity. Single-walled carbon nanotubes can behave as either metallic or semiconducting depending on their chirality. The fourth property is thermal conductivity. Have an exceptionally higher thermal conductivity surpassing that the conventional materials. This property combined with your small diameter make carbon nanotubes efficient thermal conductors. So now moving to the next slide. So the next property is optical property. Carbon nanotubes has unique optical properties including absorption and emission in the visible and near infrared regions of the electromagnetic spectrum. The next property is gas and molecular absorption. Carbon nanotubes have a high surface area which make them suitable for gas and molecular absorption. This property is used for gas storage, separation, and sensing applications. So next slide. The next property is chemical reactivity. The outer surface of carbon and it can undergo various chemical modifications allowing for functionalization and the attachment of different molecules. The next property is nanofluidics and capillary actions. Carbon nanotubes can act as nanoscale channels in fluid transport at the molecular level. So these are used for implications for nanofluidics, filtration, and drug delivery system. So here we discuss about the understanding of dynamic behavior of carbon nanotubes. There are 6 methods for understanding the dynamic behavior of carbon nanotubes. These methods are vibrational modes, Raman spectroscopy, computational modeling, resonance and mechanical properties, mode localization, and damping vibration based sensing. Now we discuss that why the vibration analysis is so important. Basically, there are 3 purposes of vibration analysis. The first one is predicting and optimizing mechanical properties of carbon nanotubes. The second one is designing nanoscale devices and sensors. The third one is accessing structure, stability, and reliability of carbon nanotubes. So for the next slide, here we are going to discuss vibrational modes in carbon nanotubes. There are basically 3 modes of vibration. The first one is radial mode, the second one is breathing mode, and tangential mode, and longitudinal mode. So the first one is radial breathing mode. The radial breathing mode refers to the expansion and contraction of the carbon nanotubes diameter in a radial direction. The second version is tangential mode. This mode inverses in plane, bending, or twisting vibration of the carbon nanotube structure. These vibrations occur within the plane of nanotubes and can manifest as bending, buckling, or twisting motions of the carbon nanotubes. The third one is longitudinal mode. Corresponds to the axial stretching or compressing vibration along the length of the carbon nanotubes. So the next slide. And now we discuss about the vibration analysis techniques. There are 3 basic techniques for vibration analysis: molecular dynamic simulations, density function theory, and Raman spectroscopy. The molecular dynamic simulations are computational methods used for novel and similar the dynamic behavior of the carbon nanotubes. Density function theory is a quantum mechanical modeling approach used to calculate the electronic structure and properties of material. And the third, Raman spectroscopy, is an experimental technique widely used for vibration analysis. So, next slide. Now we discuss about the characteristics of molecular dynamic simulations. So there are basically three characteristics of molecular dynamic simulations: simulating atomic interaction, analyzing carbon nanotubes, vibration, and visualizing vibration modes and frequency distributions. So in the next slide, so these are the characteristics of density function theory. There are three characteristics of density function theory. These are the quantum mechanical approach, calculating frequencies and determining carbon nanotubes behavior under the different environmental conditions. These are the characteristics of Raman spectroscopy. There are three basic characteristics of Raman spectroscopy. The first one is it is non-destructive experimental method, the shining laser light on CNT, and the analyzing scattered light, and the third one is an identifying vibrational modes and frequencies from the Raman spectrum. In the next slide, there are many applications of vibration analysis. Some of the listed here. The first one is composite material with enhanced properties. Second one is nanomechanical sensors and actuators, energy storage devices, and nano electrochemical systems. In the next slide, we discuss about challenges and future directions that can help us understand the influence of effect on CNT's vibration. It is developing more accurate and efficient computational methods and models. It is exploring vibrational properties of other nanomaterials. So here I am concluding this discussion here on vibration analysis. So the vibration analysis provides a valuable insight into the dynamic behavior of carbon nanotubes. This analysis is crucial for designing nanoscale devices and understanding material properties. These ongoing research continues to expand our knowledge in this field. So, at last, thank you for your support and listening.